From Los Alamos National Laboratory, this is the National Security Science Podcast.
So we're launching a rocket today.
This is our Space Loft rocket. And so this is a mission dedicated for Los Alamos National Lab.
I mean, just to be able to come out here to a pad and stand here just hundreds of feet from an actual rocket that's about to launch.
This is my first launch. Everything's new about this experience, coming out in the middle of nowhere, bright and early in the morning, and the nerves about what is going to happen.
Welcome to the National Security Science Podcast, the podcast for the Los Alamos National Laboratory's National Security Science magazine. I'm your host, Brenda Fleming, and today magazine writer Jill Gibson and I are going to tell you about our recent trip to Spaceport America in southern New Mexico, where we got to watch the lab conduct a rocket launch.
It was really fun to be able to watch Los Alamos and its partners conduct this launch. The goal was to test new technology, and spoiler alert, the launch was a complete success.
The purpose of this launch was to test the performance of a deployable heat shield called an aeroshell.
The aeroshell is a heat shield structure that protects the rocket's payload. That's the systems and components that the rocket carries into space. The aeroshell protects the payload from excessive re-entry heating. It also slows the descent of the payload by using a folded metal structure that opens like an umbrella. This ensures that the payload can survive its drop back to Earth, which can reach speeds greater than 2,000 miles per hour.
We should also explain that Los Alamos uses flight tests like this one to analyze the performance of weapons-related technology under extreme conditions, such as zero gravity, re-entry heating, and high accelerations. Flight testing provides information on how systems behave in extreme conditions. These tests create environments similar to those that nuclear weapons components and systems would need to survive during a real intercontinental ballistic missile launch.
The other cool thing about this launch and this new technology was all the partners that worked together to make it possible. You'll hear a lot more about that throughout this podcast. But let's start with the day before the actual launch, when we joined everyone invited to the launch for a tour of Spaceport America.
Spaceport America is a state-owned commercial launch and flight testing facility that enables both private spaceflight, like Virgin Galactic's space tourism missions, and federally sponsored rocket testing and aerospace research. Up Aerospace, the company that built the rocket, maintains a launch complex and payload processing facility at Spaceport America's vertical launch area. That's where we got a close-up look at the rocket that would carry the lab's new technology into space.
Hi everyone, welcome to the Launch Complex 1. My name's Eric Larson. I'm the program manager for Up Aerospace, and this is our Space Loft rocket.
Eric explained how the 20-foot-long rocket worked using solid rocket propellant and a fixed rail system to launch the unguided rocket into space.
So it takes just a couple of minutes to get up to space. Once when it's in space, the payload will experience microgravity for approximately 3 to 4 minutes, depending on the actual altitude. And then everything will be recovered on the other side of the mountain. So the White Sands folks are kind enough to send a Black Hawk helicopter over here at Pad 2, just by our facility there, pick us up, and whoever else is required for recovery will fly over there, pick it up, bring it back, and then we'll show it off to everyone.
Eric told us that the rocket and the deployed payload would come down on nearby White Sands Missile Range. He predicted that the actual flight would take less than 15 minutes if everything went according to plan.
One of the cool things about viewing the rocket and going on the Spaceport tour was seeing how excited all the guests were. The Up Aerospace team gave some of the kids in the group toy rockets to play with. Watching them play reminded me of how fascinated people are with space and space travel.
I am making a rocket launch in place here right now.
The kids had a great time on the tour and during the actual launch, but so did the grown-ups. While this was a suborbital launch, meaning the rocket didn't go high enough to enter the Earth's orbit, it did go to outer space. I grew up in New Mexico, and I never would have predicted that the state would one day build a facility that would launch rockets into space, all in our own backyard.
New Mexico has a lot of advantages for flight testing, and these facilities make it convenient and affordable for the lab to test new technology. That's something we learned a lot about during the launch.
Exactly. Let's listen to Los Alamos project manager Jordan Shoemaker talking about that.
New Mexico is great to work in, and it's great to be able to come down, just drive a few hours down from Los Alamos to Spaceport America and to additionally our partners with White Sands Missile Range. To have this be a local New Mexico effort is a fantastic opportunity for both our state as well as it contributes to its capabilities to reduce cost and reduce the travel burden on all of our teams to be able to execute these experiments. And to be able to execute an experiment of this caliber on such a short timeline and for such a reduced cost, it speaks volumes to the tenacity of the teams as well as the progress that we're making as a program on getting to a more agile, responsive enterprise.
Jim Wren was the Los Alamos project lead for this launch. He also commented on the many advantages of being able to conduct this flight test close to home.
Yeah, it's a great site to test from. Great support from New Mexico and the community here. It's faster and less expensive, and we learn more and are able to apply those lessons more quickly to future flight vehicles and have more rapid advancement for our hardware development.
Speaking of hardware development, the Los Alamos team worked with several partners to construct this aeroshell. One of those was Redwire Space. Engineer Nathan Pearson explains how Redwire helped design and build the deployable aeroshell.
So we started from scratch, complete blank slate, developed requirements with Lanol, worked with them along the way to iterate on different concepts, designs, prototypes, and this is a first of its kind deployable aeroshell being tested today.
One of the coolest things about the aeroshell is where the engineers who designed it got their inspiration. Nathan explains.
This one is unique because it's inspired by origami in the way that it conforms to the body of the vehicle, and then it deploys and forms a solid deployed shell to act as the aeroshell as it re-enters.
Redwire Space in Los Alamos also worked with the NASA Ames Research Center to build the aeroshell and plan this flight test. NASA Ames develops entry system technologies that help enable NASA missions. Engineer Paul Wersinski told us about their role as consultants for this new technology.
So at Ames, we have designed the shape of the heat shields, the materials that go into the heat shields to keep everything protected, keep your payload safe and surviving. So up to now, NASA, other groups have always made rigid heat shields, these solid heat shields. And what's the recent breakthrough has been the development of these heat shields that open up like an umbrella. We developed that at Ames to carry payloads up to big sizes, up to multiple metric tons. Think of umbrellas now, instead of just a meter in diameter, now maybe 5-10 meters in diameter. That's what we're aspiring to do. We have groups that can predict the forces, the heating environment on vehicles. We also do trajectory simulations, so we can also model where it's going to fly over time. It's been a very fun collaboration.
Collaboration was a word we heard a lot during this flight test. Los Alamos engineer Justin McLone mentioned that as well.
There's a lot you can do on the ground, there's a lot you can do in simulation, but you can't totally recreate the environment of spaceflight without basically doing spaceflight. So this gives us the combination of zero-G, vacuum, re-entry heating, high velocity, hypersonic flow, all the things that are required to survive the actual flight environment are really hard to recreate without a flight environment. So, in the end, just flight testing is the best way to do that. Now that we have these commercial rocket companies providing us, fairly frequent, affordable flights, it's just much faster to just go out and build something you think will work, instrument it up, and then fly it and test it, and then iterate and improve on it. You'll make much more rapid progress that way on the engineering. And then you have the confidence that, well, we know it works because it worked, right?
Speaking about working, I bet listeners are eager for us to get to the actual day of the flight test.
The launch was scheduled to take place between 7 and 10 that morning. but we had to get up at 3 a.m. to drive to the launch site.
And when we got there, it was pitch black outside. We parked our car in what felt like the middle of nowhere, and here's what happened next.
All right, here goes nothing.
I got that.
Okay, so nothing is starting till at least 7, right?
Yeah, why are we here so early?
I think so they can lock up the
Gate.
like button everything up.
So where do we go from here? It's so dark. Where do we go? It's dark and cold. And as you can hear, it was also windy. Using our phones as flashlights, we walked across a field to a group of people gathered in the dark.
You guys excited? Yeah. Did you listen to like a space-themed music on the way down here?
Brenda was upset that we didn't have a space playlist for the drive.
Yeah.
There's like a NASA space launch Spotify list.
Really?
That's funny.
We'll have to look that up.
One of the people gathered in the darkness was a key member of the Los Alamos project team, Sophia Wu. Sophia, what are they doing now?
Countdown procedures. So far, they've launched the first weather balloon at 4:40ish. Within T-minus 60 minutes on the count, they'll launch another one to check winds again, just to double check the firing angle. So this is an unguided mission, and basically they launch a weather balloon to make sure that the winds at higher altitudes, like we're still gonna like follow our trajectory, and they adjust that by adjusting the angle of the rail. So that they'll do another final check, and right now they're going through final checks. And so I think there's a little bit of like we're waiting for 7, but there's also like we're going through the checklist as scheduled.
Is this like a windy morning for a launch? Feels pretty breezy.
I think it's anything under 8 miles an hour is fine. Once we get to 12 to 15, it's a little dicey. But I think we care less about the winds here than we do up there.
Okay.
A couple thousand feet up.
So that's why the
really
balloon.
Yeah, that's why we care about the weather balloons.
Sophia needed to get back to work, so we went to set up cameras and recording equipment. As the sun slowly began to rise, we found Jordan Shoemaker. What are we doing?
So we're launching a rocket today, and it will be the payload that we've been working on for the past 2 years. It's a deployable heat shield, so we're going to deploy the heat shield after the payload deploys after apogee, and learn about the performance of the vehicle on the way down. We hope to learn about the aerodynamics of the vehicle as the deployable heat shield deploys, and we'll take inertial measurement unit measurements, as well as GoPro camera feed on the performance of the vehicle as it's coming in.
Everything was going according to plan, and the morning passed quickly. Precisely at 7 a.m., the countdown began.
3, 2, 1, fire. Missile away.
After the launch, the retrieval team departed in a Black Hawk helicopter to collect the aeroshell and rocket that had impacted the Earth on White Sands Missile Range. Less than an hour later, as a crowd of onlookers watched, they returned, having successfully located the aeroshell and other rocket parts.
The team examined the aeroshell. It was a little sandy and slightly bent, but survived the test intact. Everyone said they were pleased with the initial data from the launch and called it a success. Los Alamos engineer Jacob Pratt said the morning marked the culmination of many years of work.
Yeah, been working on it for almost 3 years since I started at the lab. Exciting to see it fly and work so well. A lot of testing went into it, a lot of practice, so day launch went smoothly. Yeah, a lot of long hours and hard work. It's nice to work with so many great people.
Jacob said the team would have to wait a few days to get the final data and the video from the GoPro cameras on the aeroshell. He said he was looking forward to seeing that video, and he was already planning the next flight test.
And as we wrapped up the morning at Spaceport America, Jordan Shoemaker had one final comment about the test.
This is one of many, is the last thing I'll say, that it's paving the way for this new approach that we're taking for a deployable heat shield, and this technology that we're developing. We look forward to doing a lot more of them with Spaceport America, with White Sands Missile Range, Redwire, and additional collaborators to come.
We'd like to thank all the collaborators who made it possible for Jill and me to witness this Los Alamos National Laboratory rocket launch and share it with our listeners. To learn more about the role of flight testing at the lab, check out some of the National Security Science magazine stories listed in the show notes.
Thanks for listening to the National Security Science Podcast. For more great stories from Los Alamos, visit www.lanol.gov/magazine.